Hello. Hello, hello. Can you hear me? Hello, can you hear me? Hi. Can? Okay, that's very good. Thank you. Hi. Hey, why every time you ask, is there Kahoot today? So funny, y'all. Kahoot, the Kahoot, not today. Yeah, the Kahoot, I think the Kahoot is for P5 math. Friday, I think, if I'm not wrong. Hello. First one. Ah, yes. We're gonna start in about 3 minutes plus. Okay, there's a countdown over there. Okay. Oh no, why? Why you don't like energy? Yeah, P6 this year. Have you learned forces? Oh, mm, yeah, yeah. It takes a while to understand the conversion. But have you learned forces yet? I think forces might be a little bit harder than energy. Yeah, energy conversion is the easiest to explain, right? As long as you know like how one energy is converted to the other, then it's very easy to do those explanation questions. In P5, Sukuna. Hmm? Sukuna, that sounds very familiar. Is this some anime name or something? So they don't have Kahoot. Yeah, JJK, right? Jujutsu Kaisen, right? Cannot start now. I must start on time. Hello, Ruti. They said 7 to 8, right? So you cannot start now, okay? Yeah, Jujutsu Kaisen. Yeah. I have, you all know who is this? Hey, You Are My Special is the the opening song for Jujutsu Kaisen. See this one? You all know who is this, right? Yeah, yeah. Yeah. Then you all know, those of you who watch anime, you all know who is this? Oh, yeah. No, not. Can't see. No, he's. Ayo. This is not Naruto. I give you a clue. It's from My Hero Academia. Okay, we're gonna start in 28 seconds. Just follow the countdown on top, okay? Today don't have Kahoot. Today's Kahoot is today don't have Kahoot. Is for this week's Kahoot is P5 Math. Yeah, no Kahoot today. Wow, so many cards. Got Gojo or not? Do you have Gojo cards? Okay, everybody. I'm going to start. All right. So, okay, everybody. Just to let you all know. Okay, we actually have online classes. Okay, it's right on top. All right. For P5 to P6, English, Math, Science, and Creative Writing. And then for Secondary 1 and 2, we have online classes for Math. All right. So, if you want, there's actually a free trial you all can go and try. Okay. So let's start with today's lesson. Okay. Hey, hello. Hey, stigma. Yes, stigma is the female part of a flower. Okay, so today we'll be going through forms of energy and forces again. Okay, because a lot of you, I believe, your school are still either on energy or talking about forces. All right. So which school is on energy and which school is on forces? Hello, ABC. Why you call yourself ABC? Okay, all right. So everybody, I'm going to start. Okay, so I'm going to show you this part of the question first because the top part is going to block my question. Okay, so I'm going to show you part of the question first. Okay. Oh, so yeah, that is hot. Yeah, you know. Okay, so yeah, energy and forces. Yeah. Oh, some of you on forces already. Okay, very good. So let's look at this one. Okay, you eat dinner, you eat and watch. Is it WL? Okay, over here, let's look at question 1. Okay, so over here it says that Jane placed a wooden block on a sheet made of material X. So every time you are doing science question, always remember to highlight the key points. Okay, so over here, we know that it's made out of material X. Okay, what happened is she gave a block a push at point F. It moved forward by a distance, stopped, and stopped over here, as shown in the diagram over here. Okay, so they said using the same amount of force, okay, to push the wooden block at point F, she repeated the experiment for materials Y and Z, and she recorded her results in the table below. So every time when it comes to experiment, always identify your change variable. Oh, eat your dinner already? I haven't eaten yet. So good. What's my change variable, everybody? Do you know? A change variable. You're spamming your answer already. Change variable? That's not the distance. Change distance is the measured variable. Distance D is the measured variable. Something that the person record, okay, is the measured variable. Distance D is the measured variable. Does anyone know what's my change variable? Do they know Kahoot? Yes, it's the materials. So the material, different material, you see, initially is material X. Subsequently, the person tried it with Y and Z. All right, so different material. Material is my change variable. So let's write that one down. Very good. Okay. Yeah, no Kahoot today. Hey, why you every time ask about Kahoot? You should ask, what am I learning today? Okay, let's look at this. Jill wanted to use one of the materials for the flooring for her elderly parents so they do not sleep easily. Okay, she don't want her parent to fall down easily. So based on her results above, arrange the material from the most to the least suitable, which you should use for the flooring of the bathroom. Okay. Yeah, we're learning about energy and forces. Okay, so everybody, you must, okay, so if I don't want them to sleep easily, this topic, what topic do you think this question is asking you about? You all know what topic do you think this is about? Very good, Yuki. Forces, right? So, yes. All right. So, can you tell me if I don't want them to sleep easily, what kind of force, okay, must be there? What kind of force must I focus on? Very good. It's frictional force, right? So, if So tell me about frictional force. If I don't want them to slip easily, means that frictional force must be. Oh, I heard someone just now, you all asked for my name. I'm teacher Jody. Oh yeah, so frictional force must be high or low? Does it, you know, frictional force must be high or low? Very good. Yan Zhang, very good friction. Very good. It's friction. Yuki, friction. Ah, yes, frictional force must be high. Hey, hello, I don't want them to slip easily. So frictional force must be high. High frictional force. Okay, that friction, because frictional force prevents you from falling down. So if I don't want you to fall down easily, I want to have more frictional force. Okay, so if it's more friction, when I want more friction, means the material must be rougher, right? So if I want a rougher material, what should be the distance? It must travel very far, means it's rough, or very near, then it's rough. Why are you sad, ABC? Do you know? If I want more friction, it should travel further or nearer? Your fried rice very nice. Don't make me hungry, capybara. Hey, rough eh. If you push a ball on a rough floor, right? Will the ball travel very far, or it will stop? You cannot travel so far. What do you all think? Any idea? Any idea? Yeah, it cannot travel far, right? If it's rough, it cannot travel far. So based on this, which material cannot travel far? Yes, if it's rougher, means it will not be able to travel so far. So which material, everybody? Just now I see some of you already sending your answers very early. Yes, it's Y. Very good. So Y. Okay. Cannot travel far, so it's the roughest. How do you know it's the roughest? It's the least distance. It travels the least distance. Okay, which means that it has the most amount of friction. So I'm going to choose Y first. All right, so then after that, followed by what? Which one? After Y, it will be after Y. What's the next one that has the most amount of friction? What is MT? Teacher Jolene? I have no idea who is Teacher Jolene. Okay, but X. Yes, very good. X. And after that, Z. So very good. Some of you just now send your answer too. I actually seen your answers, okay? So very good. Yes, the answer is number 2. All right, let me just scroll up a bit so you can see the answer. Okay, very good. Thank you. All right, thank you for all your answers, everybody. Yeah, I'm Teacher Jody. Yuki? Yuki, who are you? Do I know you? Yeah, I'm Teacher Jody. Okay, everyone done? Understand? Do you have any questions for this so far? Any questions? Yeah? Yeah or no? I see someone say yeah. No? Okay, then I'm gonna move on. Okay, hope you understand, okay? The rougher the floor, the rougher the surface, the more friction it has. So the object cannot travel so far. Okay, Ken? Alright, so let's move on to the next question, question 2. So which of the following forms of energy are useful? Oh, hello, Isabella. Okay, everybody, useful. So I want useful forms of energy for the fan to function. Read the question properly. Function means what? The fan actually have what kind of, actually use what kind of useful energy? Electrical, yes, I saw someone. Yes, capybara lover. Yes, very good. Do you all know? If you all know the answer, you can straight away send to me. This is a straightforward question. Okay, so yes, what happens is that electrical energy is needed is used by the fan to work. What else? Hey, I seen 1 and 2. So which one is it? Okay, yes. Okay, most of you actually put 2. Very good. So yes, 2 is the correct answer. It's supposed to be C, kinetic energy. Okay, why kinetic energy? What's the kinetic energy for? Yes, Yan Chang, very good. Yes, Don Donkey. I like Don Donkey. I like to go there to buy things. uh, it's for what? Yes, it's to turn the blades of the fan. Very good. So kinetic energy is used to turn the blades. Okay, it's turn the blades of the fan. So not heat and okay, so everybody, there is also heat, but is heat useful in this case for the fan? Do you need heat energy for the fan to work? No, correct. So because of this, that's why I highlight the word useful. Very important. Heat energy is present, is produced, but is converted to heat energy, but it's not useful energy. Okay? Can sound also, there'll also be sound. When the blade spin, there's a lot of sound, right? But it's not useful when it comes to the function of the fan. Okay? So this one is not useful. Okay, so the answer is number 2. You understand? Why is it not like heat or sound? Okay, yes, okay, very good. All right, so everyone clear so far? Yeah. What noise your cat like? You have a cat? Oh, I like cats. Okay, everyone, again, I'm gonna move on. All right, these are also very straightforward. Which of the following possesses not the other kind of possess, okay, not the horror kind, just which of the following have potential energy? Potential to kinetic. Yuki, you're talking about the fan? Are you talking about the fan? Hey, Mayuan. I also know from 1 to 4, one of it is the answer. Which one do you think it is? Okay. Everybody, most of you are correct. Number 4. Okay. So most of you are correct. What happened is that okay, can you tell me? Very good. You all know that all of it has potential energy. Can you tell me to be specific? Oil has what kind of potential energy? All of you are correct. Number 4, that's the correct answer. But let's be a little bit more specific. Oil have what kind of energy? Very good, Valerie, Rose, etc. Okay, yes, Ryomen, Sukuna. Okay, very good. Oil has chemical potential. What about food? Okay, I've seen a lot of you also say chemical potential energy. All right. So what about batteries? What about batteries? Okay, very good. Also chemical potential energy. Okay, what about stretch rubber band? What about stretch rubber band? Very good. Elastic potential energy. Okay, so very good. So let's write this one down. Okay, so all of you are correct. The answer is number 4. Okay. Understand? Okay. Does anyone has any questions so far for this? No? Okay, good. All right, so let's move on to the next one. All right, so let's look at question 4, which is a little bit tougher now. All right, so I'm going to show you half of the question first, okay? Because later it will be blocked. All right. Oh, you're about to have your dinner? Why you're making me hungry? Later I'll eat after the live. Okay, so let's look at this. All right, so Josh jumps off a springboard into a swimming pool as shown in the diagram below. Kolomi. You are? Your name is Josh? Oh, hello, Josh. Okay, so over here, right? what happened is he bounced off. Okay, I'm going to highlight the key thing. Everybody, you need to, in science, try to highlight all the important things, okay? So what happened is he bounced off the springboard at point L. Okay? Then he reached the highest point M with a slight pause before coming back down. So take note of all the key things. Highest point, there's a pause before he comes back down. Everyone okay so far? Okay, then let me ask you a few things first. Yeah, this topic. Okay, yeah, this is P6. Y'all can see, right? The live info should be P6. Yeah, P6 science. Yeah, okay, so for this question, okay, let's focus on energy. All right, so if there is a springboard, can you tell me that? Oh, yes, you're correct. There's actually gravity all around, all the time. Okay. So can you tell me what kind of energy does he have at the springboard? Yes, Yuki, that's not wrong. You're correct. Okay, very good. Jing, is it called Jing? Yeah, Jing. Yes, it's elastic potential energy. Okay, so very good. So over here, because of the word springboard, okay, we must know that there is elastic potential energy. Okay? Solomon, not gravitational yet. The boy do have gravitational potential energy because he's at a height, right? Okay, but if you're focusing on the springboard, the springboard is the one that allows, like, give him the energy to jump, okay, or let the energy be converted so that he can go higher. Okay, all right. So over here, the elastic potential energy. Everybody, okay? Oh no, Solomon, it's okay. Is it you forgot all the things already? Okay, so everybody, how about if the person bounced off, what do you think happened to this elastic potential energy? It's been converted to what? You all know? Yes, Iris, very good. Okay, so this elastic potential energy is then being converted to with push energy is that one is force. Usually push and pull is force. So if it's energy, very good kinetic first, right? So when he bounced off the board at L, okay, there is some sort of movement. Okay, movement, which also means that there is what? Kinetic energy. Movement means kinetic energy. Very good. Hey, all of you are doing well. Yeah, I am. Oh, you asked me whether I'm at home. So after that, he reached the highest point. Okay, so if it's highest point, what kind of energy is that? Do you know? Energy? What kind of potential energy? Yes, it is gravitational potential energy. Okay, very good. All right. So this is gravitational potential energy. So let's write this one down. Highest point, there would be gravitational potential energy. Okay. Everyone okay, Ken? All right. So, okay. So based on this, all right, what happened is that you need to understand, okay, why is there, okay, so I go down a bit, okay, the diagram very big. So you try to remember, okay, what are the main forms of energy that Josh possesses while he's jumping off the board at point L and when he's at point M. Okay, you all look through the options. What do you all think it is? Any idea? Okay, 4. I've seen 4. I've seen 4. Then what happened? I've seen 2. Why got 5? Why is there 5? So funny, yeah. What do you think? Okay, so okay. Okay, the correct answer is 4. Let me explain why. A lot of you are correct, okay? So the correct answer is 4. All of you, most of you are correct. Okay? So, why? Okay, so what happened is, all right, at point L, okay, you all must understand that, hello, concentrate on this question, please. Okay, so jumping off the board at point L means that what happened? All right, that, why you all? Hey, hello. Why you all like that? Okay, so take note that there is kinetic and potential. Why kinetic and potential? Because just now someone said already, right? The person is at a height. So when the person is at a height, there is gravitational potential energy. Okay, understand? Okay, then after that, all right, there is also kinetic because why? There is definitely movement here. Okay, understand? All right, so everybody okay? All right, so over here, not only kinetic, not only potential, at point L, there must be both. Okay, and for point M, everybody okay? Chemical potential energy from where, Rose? Yeah, elastic potential, that I wrote it here already. It's under the same category as potential energy. Okay, Ken? It's under the same category as potential energy. Okay, so there's two kind of potential energy. Okay, Ken? Why? Okay, everybody, yeah, there will be sound and all that. But you must know, no, we must always choose the most important energy, that one that is being converted to other forms. Is the sound energy converted to other forms? Is the sound energy converted to other forms over here? Is it included in my main energy conversion? No, right? So we don't, that's not our main focus. So the problem with energy topic, right? A lot of students keep thinking, oh, got sound also. Oh, got heat also. I must write it down. No, only write down the main form of energy. See this word? Main. How do I mean, how do I know whether it's main? Is when it can be, is being converted to other forms when he jumps. Okay? Can? Everyone okay? All right, Ken. All right. Oh, okay. Your teacher say you have a lot of potential also. That's good. What? Okay, Ken. Where can you get this paper? You can actually get through our link. The link is in our bio. You can go to A Grader, then you put live. Maybe you just Google it. It should appear. Then you can actually download the worksheet. Okay, Ken? All right. So, okay, everybody understand this part? Okay, that's why we don't put like chemical potential. It's not wrong. He have chemical potential also. That's why all under this potential energy. Okay, so what about point M? Point M, why is it number 4? What kind of energy should I focus on, the main energy on at point M? Which kind of potential energy? Does you know? This should be in swimming lessons. Why you want to learn that in swimming lessons? Oh, yes, it is gravitational. Iris, very good. If we want to focus on the main form, all right, when he's going up, m is at a greater height, right? So we focus on the gravitational potential energy. Okay, so and why do we not choose kinetic? Do y'all have any idea why? Why cannot be like kinetic plus potential? Do y'all have any idea why? Highest point, okay, highest point means what? There's a clue in the question. I see whether y'all can spot that clue. Yes, he paused. Very good. So the clue, the slight pause, tells you that at the highest point, at point M, there is no kinetic energy. Understand? Yes. Okay? Hopefully you all can understand, all right? Okay. So let's move on. How long you pause? Slide, no? The exact minutes and seconds, I wouldn't know. Maybe just 1 second. Okay, so the answer is number 4, okay? You understand? Does anyone has any questions for this? No, me? Yes, Ting, do you have any questions? Your me means what? You have a question? Ting, do you have a question? No, huh? See you quite silent for a moment. Okay. Huh? What do you mean by kinetic energy equals no potential energy? No, not definitely. Let's say an aeroplane, right, is flying in the is like flying the sky. The aeroplane has what? Has kinetic energy, right? Has a lot of kinetic energy. It's flying, it's moving very fast, but it will also have gravitational potential energy. So does not necessarily means that like kinetic energy means no potential energy. Okay, Ken? Depending on the situation. Okay, everyone, all right? Yeah, depending on the situation. Okay, I'm gonna move on. No problem. Okay, so I'm gonna move on. Okay, so next one, let's go to open-ended, your favorite. Just now we went through forces already, Rose. There was a question here. This one is about forces. Question 1. Yeah. Then later there will be also. This is forces. This one. Question 5. Not your favorite. Why you all say no? Oh goodness. Why you all say no? Oh no. Okay, so question 5. Okay, question 5. Let's look at this question, okay? It says that the diagram below shows Max cycling up and down a slope. Huh? Forces brings your grade down. Don't worry. You just practice more. You learn from the life. You should be able to score better. Okay? So, hey, why are you so bad? Oh, yo. Okay, so the diagram below. Hey, Josh, this is about forces. I give you a clue already. So forces, we don't talk about kinetic energy, okay? So, okay, the diagram below shows Max cycling up and down the slope. And we have to explain why Max needed to exert more force to go up than to go down the slope. I'm very sure y'all can recall, right? Oh no, you're climbing the stairs, right? Wow. When you climb up the stairs, it's so tiring than as compared to you climb down the stairs. Okay, so why? Do y'all have any idea? Hey, not the bicycle road now. You must explain in terms of forces. Okay, Yuki. Okay. Don't say more gravitational force. Gravitational force acts on both of them. Is the same because its mass never change. Remember what are the factors that affect gravitational force? It is the can you remember a factor that affect mass, right? Try not to put weight. Okay, so in science, in primary school science, we focus on the word mass. It's slightly different. Okay, so do you remember what is mass, right? Mass is the amount of substance in an object. Okay, amount of matter in an object. So his mass, did the mass change? Yuki, yes, you got the idea there already. Yes. You got the idea there. Okay, so you must understand a Chick-fil-A lover. Rena, your one is not you're in secondary school, is it? The explanation is a secondary school kind of explanation. So we focus on the primary school explanation. Okay, Rose, you are correct. Okay, so what happened is, but all the while you can, okay, so you must compare. This is a comparison question. Very good. So very good thing. So what happened is a lot of students will just say, oh, because of gravity. Then you will get it wrong already. You need to compare. So you must think, why does he need to exert more force? If he needs to exert more force, means he is going against more forces, right? So can anyone tell me, other than gravitational force, okay, so for the first diagram, he's going up, right? When he's going up, he's going against gravity. Gravity is pulling it down, but this person is going up. This person is going against gravity, is going up, all right? So what else? He's also going, yes, I seen someone, right? Yes, a lot of you, yes, he's going against friction as well. So over here, he's going against friction, frictional force, all right? So what happens here is that we need to compare. But what about the other one? Can anyone tell me the other one when he's going down? What kind of force is acting on him? He's going down. There is gravitational force as well. Very good. What else? He's going against. Oh, okay. Very good. There's also friction, right? Okay, but the only difference is that, you look over here, everybody. I highlight, okay? When he's going down, the direction of gravity is the same as compared to gravity. But when he's going up, he's going against gravity. Okay? Not wrong here. Hello. Okay, go ahead, Yuki. So don't talk about energy here, everybody. You see this word? I see y'all still keep saying kinetic. Don't mix the questions up. Kinetic belongs to the topic on energy. This one is about forces. Okay, so y'all be careful, okay? We have to focus on forces. No need to talk about energy here. Don't talk about a single thing about energy. Okay? So everybody, what is happening here is, you must say that, okay, explanation question. In A grader, we learn either, for explanation question, we learn 2 or 3 steps answering technique. Okay? So if it's 2 steps, okay, so everybody, 2 steps is for explanation without results. Okay, so this one, which means that 2 steps if it's not an experiment question. So is this an experiment question, everybody? Is this an experiment question? No, right? So we just need to write 2 steps. Okay, use 2 steps answering technique, which is describe. Okay, I write here, okay? Describe, first step, describe. Describe by doing what? By comparing. Okay, and the science concept, D means describe, S means science concept. Science concept, we talk about forces. So how am I going to answer this question? Everybody, okay, listen carefully, all right? So to answer this question, you need to say that when he's going up, okay, when going up the slope, he is going against gravitational force and frictional force. But when he's going down the slope, he's only going against frictional force. So that's comparison. Okay, so that explains why he actually needs to exert more force when he's going up the slope. Okay. Okay, can I ask y'all, whose school teacher don't allow y'all to use the word overcome? Overcome. Who say cannot? Cannot use overcome. Who say can? Whose school teacher say can use overcome? Okay, y'all just write can or cannot. Okay, me sometimes I don't know also. Can or cannot? The teacher say can? Yeah, ayo, some say can, some say cannot, right? Some, you see? Okay, so those of you who cannot, just in case, okay, y'all cannot. This is quite a common question. Yeah. Okay, so those of you who say cannot, I use going against, okay? Going against can, right? Okay, so over here, we need to say that, all right, let's compare. So how to explain? We say when going up the slope, comma, he needs, oh wait, he is going against gravitational force and frictional force, okay, but when going down the slope, he only needs to, or he is only going against frictional force. Okay? Acting against can. Acting against, going against can. Actually depend on your school teacher. Those of you who your school teacher say can use overcome, by right PSLE they also should accept. Okay, they will accept like going against, acting against, overcome. Friction. Friction is a type of force that opposes motion, BTS. If you want to know more details, I can explain later if there is time. Okay, so those friction is something that go against motion. Friction. Okay, I just give you a scenario so you can understand. Okay, so if you fall down on the floor, why your knees get scraped and then you bleed is because of friction. Okay, okay. So just remember that like the factor that affects friction, okay, is that you just compare. If you fall down on your toilet floor and you fall down on the road outside your house, which one will be more painful? Which one do you think is more painful? You fall down on the toilet floor, or you fall down the road outside, the car driving, that kind of road outside. Road, right? Yes. Why is it more painful? Because road is rougher. So there is more frictional force against your acting on your skin. So your skin will start to tear and bleed. Okay, so that is just a general thing. That's the most important thing you must know about friction. Okay, it goes against your direction of movement. Okay, okay, I'm gonna highlight. Okay, everybody, I highlight the key thing. Okay, yeah, this is a common question. I thought I reply already. This is considered one of a common question. They always ask you, okay, why? Like sometimes it's pulling a box up a slope. Sometimes it's walking up a slope. Sometimes it's riding a bicycle up a slope. They'll just change the question slightly. Okay, okay. All right, so I'm gonna highlight everybody the keywords. All right, in science, your like PSLE, they are focusing on these concepts. Okay, so you must say going against frictional force and gravitational force, or only going against frictional force. Compare. Okay, just now I think someone asked why must mention frictional force, depending on your school teacher also. Some school teacher very strict. If you never mention frictional force, then they think that you don't know that there's frictional force. Yeah, but so no harm writing the frictional force down. Okay? Okay, everyone done? Yeah, some school teachers very strict. If you never write, then they thought you don't know that need to go against frictional force also. That kind of thing. Okay? So everyone, all right, I'm gonna move on. Okay, any questions for this? No? Wow, Yuki, how come you become alpha? That's so funny, you. Okay, everyone, let's look at this one. All right, to slow down, Max applied brakes on his bicycle, and when the brakes are applied, okay, they will the brake pads will press against the rim of the spinning bicycle wheel, as shown in the diagram below. Okay, so explain in terms of forces. Everybody during PSLE, during exams, please read the question carefully. I've seen a lot of students, okay? The question asks about forces, go and tell me about energy. So you must read it carefully, okay? Please be very, very careful. Hey, you folks, thank you for sharing. You are so sweet. But I want you all to focus on the questions also. Thank you for sharing. So you'll be very careful, okay? So how does the brake pads help to slow the bicycle down? Do you have any idea? Mm, any idea? Do you notice, have you seen the bicycle's brake pads before? We don't say the brakes are going against the ground. Have you all seen? Do you have any idea? Okay, so you all will notice, yes, it's about frictional force, capybara. You're not wrong. Okay, so over here, okay, you all must understand that brake pads, if you've seen a bicycle brake pads, right? Okay, you will notice that there are grooves to make the brake pad rougher. It's not a smooth, it's not a flat, it's not flat. There is like zigzag on the brake pads is to make it rougher. So when it's rougher, there'll be like more or less what kind of force? Yeah, the wheel is not wrong, but we must write in proper English and more scientific, okay? Good, there's more frictional force. Okay, so explain again. Explain, is this an experiment? Is it an experiment? No, right? If it's not an experiment, we use two steps. DS. Okay, very good. Thank you, Rose. Okay, describe. D means describe, okay? For A grader, we teach DS or DSL. Okay, 2 or 3 steps answering technique. So D means describe. Describe about the brake pads. Talk about the surface. The brake pads are rough. Okay, brake pads are rough. Then your science concept is about forces, which increases. Okay, when it comes into contact with the bicycle, there is frictional force between what and what. Do you all know between what and what? A lot of you answer frictional force just now. When you talk about friction, you must say between what and what for this type of question? Between nothing to do with the ground, okay? Any idea? Huh? Wheel and the ground? Look here. Everybody, this is the wheel. The like front view of the wheel. This is actually the wheel. Then look at the brake pads. Brake pads between between the brake pads and the wheel, very good. Or the wheels and the brake pads, very good. Don't say the ground. The ground is at the bottom. The brake pads are not touching the ground. Okay, Ken? All right, so good. So let's write this one down. So how are you going to answer this type of question? You just have to say that first thing, describe the brake pads. So you must say the brake pads are rough. It as it comes into contact with the rim of the bicycle, there is frictional force between the brake pads and The wheel or the rim. Okay, actually it touches the rim. So I be a bit more specific. But in exam, if you write wheel, they should not penalize you. Okay, because they put rim here. So I'll be more specific. All right. So I'm gonna highlight the key things. Ayo, okay, thank you for sharing. But y'all must listen and focus, okay? Some of it is we change a little bit from those papers. So nice of you to share. Thank you for sharing your English paper one. Oh, good luck to your good luck to you, okay, for your English paper one. Okay, I'm gonna highlight. So take note. You have to mention that it's rough. Okay, when it touches or comes into contact with the rim, there'll be frictional force between the brake pads and the rim. Okay. Okay, thank you for sharing. So nice of you. Okay, everyone, all right? Okay, I'm gonna move on, all right? Okay, I'm gonna move on. Oh, wait. Okay, yes. When I'll be doing P6 science again? Next week. 8. The life is finishing at 8. Okay, I'm gonna move on, okay? Okay, let's look at C. All right, C, what happens is that this person suggested to Max he can apply oil on the brake pads so that the bicycle will slow down more quickly when the brakes are applied. Do you agree? Do you all agree if I add oil, then the bicycle will slow down faster? Hello, Belinda. Oh, sorry, I have something on Saturday. That's why I never go. There was relief teacher, right, Belinda? Yes, no. A lot of you said no. Very good. All of you are correct. Very good. So why no? Is because just now I saw someone mention oil acts as a lubricant. So what does lubricant do? It increases or reduces what kind of force? Good. Okay, yes, very good. Okay, there is lesser frictional force. Very good, Lynette. All right. Yes, thing so that he will not stop. So instead it will be more difficult for him to stop his bicycle. Okay, so let me write this one down. Very good. A lot of you are correct. Good job. Okay, so you can say that no, I don't agree. So why no? Okay, to say that oil, explain, describe about oil in terms of lubricant, and then your science concept is forces again. Okay, so you must say oil acts as a lubricant which reduces frictional force between the brakes oh hold on brakes and brake pads and the rim, causing it to slow down more slowly. Don't need to talk about contact force. Frictional force is a contact force already. So you don't have to mention contact force. Contact means the two surface needs to touch each other in order for the force to be there. Like gravity, you don't have to touch. Gravity is a non-contact force. It means you don't have to touch the surface of the earth to have gravitational force. Like the birds in the sky is not touching the ground, right? There's still gravitational force acting on it. That is non-contact. Don't need to touch each other directly. Okay, so I'm gonna highlight everybody. So we need to say that. Oh, bye-bye, BTS. Okay, so I'm gonna highlight, okay? So please remember to mention lubricant reduces frictional force between the two surfaces. So it will slow down slowly, not quickly. Okay, I'm gonna, oh, that's good, Yan-sang, good. Everyone okay? Okay, I'm gonna move on. Okay, let's move on. All right, so in the diagram below, we are supposed to draw two arrows. Okay, this one very straightforward. All right, so let's do this one quickly. Draw two arrows to show the direction of two forces acting on the stone. And we need to name the force. Okay, then you all just name. Huh? It's blurry suddenly. It's blurry suddenly, is it? Or is it your internet is lagging? No, some say no eh. Okay. Okay, I think it's the diagram that is blurry. Okay, everyone, okay? What kind of forces? Okay, good. We have frictional force and very good gravitational force. So frictional force, always remember, go against movement. Your movement is to the right. Frictional force is going to the left. Okay? And then gravity is a gravitational force, is a downwards pulling force. All right, so these would be the two arrows. Hey, very good, WL. Yeah, capybara. Some of it is from there. Okay, let's move on, everybody. Okay, I'm gonna move on. This one don't take too long. All right, let's look at question 7. Also very straightforward. This is about energy now. Okay. Oh, Chinese. Sorry, Ping. I'm not very good in Chinese. Okay, so over here, the diagram below shows a mallet. Okay, connected at point W. Alright, so what happened is it's allowed to swing freely. Okay, at about at W. Alright, when released from position A, it will swing and hit the ball. So everybody read the question properly. Main forms of energy. When it's released at position A, it hits the ball and it causing it to move. So everybody, huh? No cher, what no cher? Okay, everybody, okay? So can you tell me? Oh, Yuki, very good. So everybody, the words will give you a clue. Okay, so at position A, it is at a height. Okay, so if it is at a height, means it will have our, very good, thank you, potential energy. Okay? And to be more specific, it will be gravitational potential energy. Okay, okay? All right. Then there's a clue here. Swinging, moving. The moment you see swinging, moving, it indicates movement. Movement will be kinetic energy. Hey, all of you are very good. Very good, Yuki. Very good, Winter. Very good, Lynette. And this happy space. Thank you. Very good. Michelle, also good. WL, okay? Good. Okay, so clear. This one, I don't spend too long here. I'm going to move down. Oh my goodness. Belinda, are you all right? You're outside or what? Oh no, go and clean up, okay? Yuki must have more confidence in yourself. You can do it. Maybe you watch the live, then you slowly understand even more. Then you can score better already. Okay, so over here, let's look at the next part below. Last question. Oh yeah, this one is the last question. We do B, C. Left with part B and part C. Yeah. Okay, so everybody, the mallet can also be released from position B as shown below. Okay, then you have to look at the diagram and compare the positions. Okay, so which position, A or B, will cause the ball to travel a further distance when the mallet is released? And explain in terms of energy. Don't go and talk about forces, okay? So a lot of you chose B. I wait for more answers. Yes, very good. It is B. Good job. Okay, all of you got it correct. So why B? Can you explain in terms of energy conversion? So always first thing, explain. Okay, so when you explain, you have to two-step answering technique, describe. Very good, Lynette, but your describe is at the back, right? So very good, not wrong also. So describe about the position. Okay, so position B is higher than position A. Okay, so which means that talk about science concept, talk about energy conversion. The mallet will have more gravitational potential energy. Very good, which will be converted to more kinetic energy. Very good. Okay, so of the swinging mallet, it must be step by step. Okay, everybody, look at part A to give you a clue on what to say. Okay, more gravitational potential energy will be converted to more kinetic energy of the swinging mallet. Then it will be further converted to more kinetic energy of the ball. Must mention of the what, of the what, of the what for explanation question. Okay? Alright, so you must be, you cannot just say kinetic energy, but you never mention of the what. So you must be careful, okay? So don't talk about friction. This one no need friction. They never ask you, for B, they never ask you why it stops. So don't need to talk about friction. Okay, so the answer is B. You need to say at position B, it is at a higher height. Okay. So the mallet will possess more gravitational potential energy. Okay, everybody, I'm just going to write gravitational, okay? But during exams, right, please take note, during PSLE, the word gravitational, chemical, or elastic for potential energy is not required. Okay, but your school teacher, I know some of your school teacher are very strict. So if they want you to write, please write it down. Okay, more gravitational potential energy, which will be converted to more kinetic energy. Please use comparison words here, okay? Because you need to explain further distance. Okay, kinetic energy of the swinging mallet and converted to more kinetic energy of the ball. Okay, so that's why it can move a further distance. Okay? Oh, WL. So nice of you. Please can. Thank you. Okay, I'm gonna highlight the key thing. Higher height, there will be more gravitational potential energy, converted more kinetic energy, and converted to more kinetic energy of the ball. So nice of you to say it, remind people to pay attention. Different, what you're talking about? Different bed GE and gravity. What do you mean? Belinda, really? Okay, never mind. Saturday I go back to class, I scold Ricky. He not behaving, is it? In front of when there's a relief teacher. Okay, everybody, let's go to the last one. C. Okay, so now everybody explain in terms of energy why the ball stopped moving. That everybody, this is a standard answer. No matter what question, if they ask you why the ball stopped bouncing, why it stopped moving, why the car, why this and that, stop moving, there's a standard answer. It's Jessica, stop, totally stop, means got any more kinetic energy? Don't, this is about energy. The Xiu Ping, Krish, In terms of energy, hey, you must be very careful, okay, when you're doing the question. Ayo. Okay, no more kinetic energy. Very good. So how come no more? Because all, use the word all, don't use some. Okay, everybody. A common mistake made by students is that some students will straight away put some kinetic energy. Some kinetic energy is for explaining why the ball bounced to a lower height, why the ball slows down. Then you mention some kinetic energy is converted to something, but now it's totally stopped. So you must say all the kinetic energy has been converted to heat and sound. Okay, everybody, very good. I see a lot of heat and sound, converted heat and sound. Very good. But the keyword in front must use all. Okay, so for this, explain. All right, okay, this one very straightforward. So this one, just talk about energy. So all the kinetic energy has been converted to heat and sound energy. Okay, so please everybody remember that stop, you put all. Use the word all. All right, if the question asks slow down, then you use some kinetic energy. So don't mix these two up. Okay? All right. Please be very, very careful, okay? Yeah, no Kahoot today, I decide. So I'm gonna highlight the key thing. All kinetic energy has been converted to heat and sound. Okay, so I'll see you on next live is tomorrow actually for P6 creative writing. And we just a gentle reminder, we have online classes for P5 and P6. The subjects are above. Secondary 1 to 2, there's also online classes. I'll be teaching the P6 science online class. Okay, so Jing, what are you talking about? Can see the answers again. I put away all this. Okay, tomorrow we have P6 creative writing. All right. Okay, can I show you? Does anyone has any questions? If y'all don't have, then there's no more other questions really for this worksheet, for this slide. Hi. Face to face. Oh, I only teach on Saturdays at North Point. What time? Say, same timing. Okay, I show you. Oh my, you want to know the time? 7 p.m. Start at 7. Yeah. Okay, those of you who have nothing, any more questions? Bye. Oh, you live in Woodlands. Whoa. I have online classes though. Then you must attend the Zoom. Yeah. Okay. Thank you so much for your like and share. So nice of you all. P6 math. Okay. Those of you who are asking for P6 math, let me recall. P6 math is next week. Eh? Yeah, should be. Next week. Okay? Bye, Belinda. Yes, P6 math is next week. Okay, those of you who want to know, right, what are our schedules, you can go to our Instagram or you can go to our website, the link in bio or this, okay? A-Grader website, and we actually put our schedules out. Okay? Okay. If you have no more questions, you have nothing to copy, I'll end the live. Thank you for coming. Thank you so much for the like and share. Why you want to get my signature on Saturday, Belinda? when I become a superstar, then you take from me, okay? And you take my signature now, no value. Okay. Yes, Josh? Oh, bye. Thank you, WL, for breaking the record. You do some business. What business are you doing? Okay, bye-bye. Okay, WL, thank you for coming. Bye. Yeah, ending already. Don't need to share already. But so nice of you, WL. Okay, bye. Okay, I'm gonna end. See you next week again. Next week, Wednesday, I'll be doing P6 science again.